Welcome to The Explainer. Today, we're peeling back the curtain on the AI tools that are, well, they're changing just about everything. Large language models. We're going to get right into how they actually work, and it all starts with a simple little puzzle that, believe it or not, reveals the whole secret.
Okay, so check this out. On the left, we give a super powerful AI a pretty basic math word problem, and it completely fails, gets it wrong. But on the right, we give the exact same AI the exact same problem, we just add one tiny little tweak to the question, and bam, it nails it. Perfect score.
So how is that even possible? What's the magic trick here? Well, it's not the model. The key, the secret to the whole thing is how we asked it to think. And understanding this one simple change is going to unlock for us how these incredibly complex systems really operate.
To crack this mystery open, we've got to go back to basics, to the absolute bedrock of how this all works. And here's the fundamental secret. To a machine, words aren't words, they're just numbers, and the relationships between them. Everything is built on this one idea.
So how do they do that? Well, it's this really cool technique called word embedding. It's the process that takes every single word you can think of and turns it into a set of coordinates, a specific point in this giant multi-dimensional map of meaning. Here's a great way to picture it. Imagine all of language laid out like a giant constellation in the night sky. In this star map, words that mean similar things like car and automobile, or happy and joyful, they're like neighboring stars clustered really close together. Their distance and position tell the AI about their relationship.
Now here's where it gets really mind-blowing. We can actually watch language itself evolve over time. By looking at texts from different eras, researchers can literally track how the coordinates for words move. I mean, just look at the word awful. Back in the 1850s, its vector was close to words like solemn and awe. Fast forward to the 1990s, and it's drifted all the way over to hang out with horrible and terrible. It's a measurable, mathematical shift in meaning.
Okay, so the AI has this amazing meaning map, right? But before it can even start plotting words on it, it has to do something much more basic. It can't just read a whole sentence at once. It's got to chop it up into pieces it can actually handle.
And that first mechanical step is called tokenization. I know, it's a bit of jargon, but stick with me. If understanding language is like cooking a gourmet meal, tokenization is just the boring prep work. It's the chopping of the vegetables. The model takes a sentence and dices it into these little units called tokens.
It's a pretty straightforward process, but it is absolutely critical. First, as you can see, the text gets normalized. Simple stuff like making everything lowercase. Then it gets split up by spaces and punctuation. And finally, a smart algorithm comes in and breaks down any really complex words into smaller, more common parts. The whole point is to turn our messy, human sentences into clean, numerical data that the model can actually understand.
All right, so now we get it. AIs see words as numbers, and they chop up our sentences into tokens. So let's tie this all the way back to that puzzle we started with, because this is where we see the real breakthrough in getting these things to reason.
So that little trick we used at the beginning, it's got a name. It's called chain of thought prompting. And it's so simple, it's brilliant. Instead of just asking for the final answer flat out, which is what we normally do, we ask the AI to show its work. We nudge it to think out loud and generate a series of reasoning steps first. And the difference this makes, it's not small, it is huge. Just look at this. On a really tough math test for AIs, a model using standard prompting got it right less than 18% of the time. Not great. But then, by just adding a simple phrase like, let's think step by step, boom, the accuracy skyrockets to over 58%. It's the exact same model. The only thing that changed was how we asked the question.
And what researchers found is that this isn't just some clever hack. It's actually unlocking a hidden ability that was already there inside these really, really big models. It turns out that once a model gets big enough, the ability to reason is what they call an emergent property. It's just lying dormant, waiting for the right kind of prompt to wake it up.
So this discovery, this idea that we can prompt an AI to reason, has absolutely massive implications. It's helping to transform these language models from just clever tools into something way bigger, something researchers are now calling foundation models.
So what's a foundation model? Well, think of it as a huge, central AI brain. It's trained on an unbelievable amount of data, not just text, but images, speech, you name it. As you see here, it takes all this different stuff and learns to find the common patterns, creating this shared space of meaning for everything. And then, this one giant model can be adapted to do tons of different specialized jobs. But, and this is a big but, This is where things get really tricky. The very nature of a foundation model means its flaws get amplified. If that core model learns bad habits or biases from all that messy internet data it was trained on, well, those biases don't just stay in one place. They can ripple out into every single application that's built on top of it. And that's how you end up with some of these really serious extrinsic harms you see here, like reinforcing awful stereotypes or creating tools that just don't work well for certain groups of people.
Which, brings us to the biggest question of all, the one we really need to be thinking about. We've figured out how to make AI perform step-by-step reasoning. But as we build these incredible systems that can think, how on earth do we teach them wisdom? Because getting a machine to reason is one thing. Teaching it wisdom is a whole other challenge entirely.